Here we are going to talk about Lewis dot structures and Lewis dot theory. This is one of the earliest theories that chemists had in order to explain bonding. It was developed by, lo and behold, somebody named Lewis. And let's take a look and see what Lewis looked like. Here's what he looked like. Gilbert Lewis, and about 100 years ago he developed Lewis dot structures and Lewis theories. The whole idea there was that atoms are happy when they have 8 electrons around them. And if you look at some of his early notes, unpublished notes, here they are. For instance, here's lithium. Lithium just has 1 dot, and going down here carbon has 4 dots, and so on. And Gilbert Lewis arranged these in terms of a cube, and cube has 8 corners, so he put electrons there, and he postulated that electrons bound in pairs of electrons, and they rearranged themselves so that every atom in a molecule would then have 8 electrons around it. One of my favorite quotes of all time in science was by Gilbert. Here is a review published in the Journal of Chemical Education about Gilbert Lewis, and it was written by his son, Edward Lewis. And if we go down here, here's a really cool quote. Edward Lewis, the son, often quotes his father as saying, "Physical chemistry is anything interesting," and that's a definition of physical chemistry that I like. So as we said, Lewis dot structures consider electrons as dots, and that means they're considered as particles. So Lewis dot structures has a different view, rather than in quantum mechanics where electrons are represented as waves. Here in Lewis dot structures they are represented as well-defined particles, and chemists represent those as dots. And the whole idea for Lewis dot structures is that you can arrange electrons around atoms so that each atom has 8 electrons around it, so-called octet rule. 8 electrons on each one. Of course, there are some exceptions. For instance, if you look at hydrogen or helium, let's look at that in bonding. Let's look at hydrogen. Hydrogen has 1 electron. Hydrogen is 1s1, so it has 1 electron. So we can write hydrogen as hydrogen 1 electron. And let's write another hydrogen here with 1 electron. Now normally Lewis structures would have 8 electrons around it, but there are only 2 electrons available, so that you would then write this in the Lewis dot structure as 2 electrons here. Or another way to write that is H with a bond, H. So this means 2 electrons that are bonding. So that's an exception to the Lewis dot structure. Also, some compounds don't have 8 electrons around them to be stable, but in fact they might have 10 or 12. Some compounds have less than 8 electrons. They might have 7 or 6. Some have an odd number of electrons. But despite all these exceptions and sort of the simplistic rule over 100 years old that atoms and molecules have 8 electrons around them, nonetheless the Lewis dot structure is quite useful. For example, in organic chemistry, one looks at reaction mechanisms and usually draws pictures such as these to illustrate reaction mechanisms. And you note here, for example, this is a Lewis dot structure on the left here as the reactant of the mechanism. And what you have are arrows showing where electrons go. And for example, this is a bond here, so it represents a pair of electrons. So these electrons go there, those electrons go there, and so on. We have something like this, and then we have that minus sign meaning a single electron, and so on. The point here is that the Lewis dot structures are used all the time in organic chemistry, showing where electrons go during a chemical reaction. So even though the Lewis dot structures are over 100 years old, they're so last century, nonetheless they're useful. What the bottom line here is that you should use the picture of compounds and so on. Use the picture that's most useful. For organic chemistry, it's not useful to solve the entire Schrodinger equation in order to figure out what happens to electrons during a reaction mechanism. For example, you just use the very simple Lewis dot structures.